Here I am, back in Chiba again on the Pacific Ocean for another episode of Astrophotography Japan. This is where my YouTube series got its start, on a cliff actually over there, overlooking the ocean. Today I'm at a slightly different spot here on the Ubara Utopia Peninsula, next to this landmark here, which I guess it's good luck to ring the bell. Obviously I come out here because of the dark skies. We're about 4 hours by train away from Yokohama, and this is Bortle Class 4 territory. And in fact, over the ocean out there, there's nothing for thousands of miles, and I got a clear view all the way east and south. So it doesn't get any darker than that. I'm hoping to image some nebulae that I was not successful at imaging in Yokohama, where the skies are Class 7 or 8. So I hope you stick around to see how everything turns out. It is not often that I take an overnight trip for imaging in the wintertime. I prefer to stay near the warm comfort of my home and backyard, but this was an exception. I have been to Chiba on at least 3 occasions in the past for astrophotography, each time to the same place just south of the city of Katsuura. The trip takes 4 to 5 trains and about 4 hours to make the journey around Tokyo Bay. It would definitely be more convenient by car and maybe a little shorter travel time, but not that much. By car, travel costs would probably be 5 to 10 times higher if you include the price of gas and tolls. So, despite the hassle, train transport is good enough. Because of the luggage I had to carry, I started my trip after the rush hour traffic, leaving my home station at about 9 a.m. This gave me the afternoon to look around and plan my astrophotography logistics at the imaging site. On the other side of Tokyo in Chiba, especially on that last leg of the trip bound for Ubara Station, the local train shrinks to only 2 cars with only 1 train per hour. Other than rice fields and peanut fields, there's not much to see. Here you can get a glimpse of the luggage I am carrying on this imaging adventure. I tried to minimize the equipment, but here you can see it still totaled 37 kilograms, or almost 82 pounds. I brought only a small 60mm aperture telescope and all the sensitive equipment like computers and cameras in my backpack. At 8 kilograms, the backpack did not seem heavy thanks to the low-pro photography backpack design. The AM5 EQ mount at 7 kilograms seemed a bit heavy to carry by hand, but as EQ mounts go, it is rather portable and light. After arrival at Ubara Station, I had to walk nearly 1 kilometer to get to the hotel. This station and town is so small, there is no taxi stand at the train station, and quite literally not even a single convenience store in the small town. As usual, I stayed at the local and convenient hotel called Yotsuba Bungalows. This is a very old and weathered hotel owned and run by a wonderful old lady who now seems to know me personally. She always gives me the best room and asks about my photos and adventures. One night costs less than $40 US, and the rooms are clean. Old and worn out, but clean, no bugs. It is a great value. From the main hotel building where I stay, seen here, it is about 200 meters down a gentle incline to the ocean. There are usually cats everywhere around this hotel. I counted 8. This small bay looks gentle today, but depending on the winds and tides, it is often a place for beginner to intermediate level surfers. And this bungalow hotel is popular in the summertime, but tonight I am the only guest. At the end of the walk, I need to turn left to access the viewing site, and from here I will show you a daytime walkthrough to the ocean cliffs where I will set up my equipment that evening. This short sequence of me with the wheelbarrow is actually filmed later that evening to show you how I transport my equipment halfway to the viewing site. I am allowed to use one of the several hotel wheelbarrows to carry my 37 kilograms of equipment, which is very much appreciated. The walk goes by a small fishing boat dock and then through a short tunnel to access the Ubara Utopia Peninsula. From this sea level location, I can push the wheelbarrow up the incline to a certain point, but no farther. As you can see from this map, I use the wheelbarrow for about a half a kilometer, but from here, the climb is too steep and with too many stairs and narrow trails to get to the ocean cliffs, so I must hand carry my equipment the rest of the way. The rest of the way is almost another half a kilometer. With 37 kilograms, this was rather challenging, but the anticipation of the night gave me the willpower to overcome. This is a Google Earth aerial view of the Utopia Cape. On the far left is where I filmed episode 1 of Astrophotography Japan. On the right is where today's imaging adventure will be recorded. Unlike the other site, today's location does not have any safety fences, which is both good and bad. Good because no fences means no interference with imaging targets close to the horizon and over the ocean. Bad, of course, for the added personal danger in the dark. If my imaging targets tonight were high in the sky, I probably would have set up my equipment down here near to the shelter, but from here, any targets below 20 degrees altitude over the ocean would be inaccessible. This is the exact site that I decided to put my tripod. It was smooth but solid rock. To the left in this photograph is a dangerous cliff drop-off, so being careful here was imperative. Fortunately, I did not bring any alcohol for my evening enjoyment. Now let me tell you about my equipment. On this trip, I have my Astrotech AT60 ED telescope, the first scope I ever purchased, just about 2 years ago. Its compact size allows me to carry it in my backpack, along with 3 ASI cameras, a field flattener, and the ASI Air Pro computer. Fully assembled, it has a focal length of 288 millimeters and a light gathering sensitivity at f-stop 4.8. On top of the AM5 equatorial mount, and with a William Optics 32mm guide scope, this imaging setup is compact but high quality and an accurate go-to imaging system. Here it is, assembled and facing north at the viewing site, waiting for sunset. At dusk, I focused the telescope manually, randomly in the northern sky, and did a polar alignment of the mount using the ASI Air, achieving a total error reported to be 35 arcseconds. But as usual, I never trust the numbers fed to me by the computer. I always double-check my results by visualizing a star field near to my imaging target for at least 1 minute with no guiding. Since my first target was near to the constellation Orion, I swung the scope to the south and selected the star Bellatrix. After a precision focus with a batten-off mask, I went to preview mode and programmed a 60-second exposure without guiding. Here is that photo after significantly zooming the image to check the roundness of the smaller stars. To my delight, they were quite round with almost no detectable trailing, confirming a good polar alignment. Under these conditions, guiding should work great with minimal stress on the system. It was time to start imaging. The time was now almost exactly 7 p.m. I put on some dew heater straps just in case, since I know from experience that the ocean side is usually more humid than the forecast generally indicates, and I slewed to my first target. That first target, and the main target I came here for tonight, was IC 2118, the Witchhead Nebula. The only chance to get this at my location is during the winter, and all my efforts from Yokohama had failed in the past since this is a dim reflection nebula. Composed of stellar dust, it is believed that the Witchhead Nebula is illuminated by the nearby bright blue star of Rigel. Shorter wavelength blue light is bent and refracted more than longer wavelengths, and hence, like all reflection nebulae, the Witchhead appears bluish in color, but very dimly. Since the blue color is broad spectrum, I surmise that either no filter or a UHC filter would be best for this target. I chose the latter and my ASI 533 MC Pro color camera because its larger sensor would capture more of this rather big and long nebula target. At 7 p.m., it had just crossed the meridian line, which meant I did not need to worry about a flip, so the timing was perfect. After some test images, I proceeded to collect data for almost 2.5 hours, where it dipped from 47 degrees altitude down to 35 degrees altitude. Here's a 3-minute single frame of the Witchhead Nebula displayed on my tablet computer with ASI Air control screen. It took me about 4 photos to frame it properly, but I finally got it positioned exactly the way I wanted it. If you look closely, real close, at this image, there are several very tiny satellite trails hidden in the star field. You do not see these very minor satellites in Yokohama, but here in the darker skies, the number of them really surprised me. Luckily, they can be ignored because they are too minor and too dim to interfere with the image stacking and processing stages later. Maybe at this point I should explain that my current style of astrophotography is usually one of exploration and image sampling. I seldom invest more than 1 to 4 hours on any target, especially when I take these dark sky trips. I'm more interested in seeing what's possible than doing a deep dive on any single target. I believe this is because I am still new to the hobby and highly interested in learning what are the limits of my equipment instead of trying to achieve perfection. I think a more mature hobbyist would dedicate more imaging time per target, but that just is not me. On this night, I actually attempted 5 targets, and I will show you the processed results chronologically as I walk you through the night. Obviously, this processing was completed a few days later after the trip, but for convenience, let's look at them during the video more or less in real time. It's around 9:30 at night now. I have about an hour and a half completed on the Witch's Head Nebula. Looking very good. Guiding is less than an arcsecond. And the sky is incredibly dark. There's no moon tonight. and it's just beautiful. The wind is calm, the temperature's not so cold, it's probably 4 or 5 degrees. There's no moon. This is like the perfect winter night for astrophotography. That's why I had to come today. So I'm hoping to complete a little bit more on the Witch's Head, and I'll probably be out here till the morning hours. So I hope I can get a number of targets to show you later. I selected and stacked 40 3-minute frames and processed the data in my usual manner using the software shown here. The square field of view of this sensor with this telescope gives coverage of 2.25 degrees of sky. And here is the image of the Witch Head Nebula. It definitely could use more exposure time, but overall I think it came out pretty well. And by golly, it really does look like the face of a witch. A curves color stretch of the full image color spectrum in GIMP naturally brought out the bluish purplish reflection nebula color, which I could not previously see in the images taken in Yokohama. These darker skies really make a difference, especially on reflection nebulae, I suspect. New nebula! Switching targets! New nebula! Funny. Pardon my silliness, but almost a kilometer away from any homes in the area, I just felt like making silly use of that bell all night long. My next nebula target for imaging was to be the Dolphin Head Nebula. This was located quite nearby to the previous target, out over the ocean in the constellation of Canis Major. Being blue in color in all the reference images I have seen, this deep sky object is not a reflection nebula, but rather classified as a hydrogen emission nebula. To appear blue, it must be primarily emitting at the 486 nanometer wavelength of excited hydrogen, which is bluish, instead of the more common wavelength of 656 nanometer, which is red. But I found a reference in Astrobin that said the blue color comes primarily from oxygen-3 emission nebulosity. Regardless, the Optolong UHC filter should be a good choice since it has high transmittance at both the hydrogen and oxygen emission wavelengths. I imaged the Dolphin Head Nebula from about 10 o'clock to just after midnight. This is a 30-second exposure taken with my iPhone 11 that night. I marked it up to show you the location of the Witch Head Nebula near Orion and the bright star Rigel, and the location of the Dolphin Head Nebula just below Sirius in the southern skies. At the time of this imaging, the Dolphin Head Nebula was between 28 and 13.5 degrees in altitude. That altitude is fairly low, as you can see in this photograph of my imaging rig with the green laser pointing toward the target. Let's get right to the point. Imaging this target was a failure. My feeling is that this target is far too faint for my small 60mm aperture telescope to collect enough light in just 2 hours. This target probably requires 5 to 10 times that long. These two images shown here are both stacked and stretched, but in different ways. The one on the left was developed with the intent to enhance the dense and beautiful star field around the central star in the nebula, Udra. I think the density of stars seen around this target is amazing, while the image on the right was processed to enhance the faint nebulosity. Unfortunately, there is just not enough nebula signal present for me to extract and generate a good photographic image of this deep sky object. To be honest, I don't quite understand this because the literature says, specifically Wikipedia and Stellarium, the Dolphin Head Nebula has a magnitude of 7, which is actually quite bright, yet I cannot capture it with this imaging rig. The literature also says the Witch Head Nebula has a magnitude of 13, yet I could capture that, which is theoretically much, much dimmer. So I don't get it. But that's okay, let's move on. This is what I mean about testing the limits of my equipment. Okay, well, I finished my nebula photography for tonight. There's not much left on the eastern and southern skies here over the Pacific that are worth going after at this time of year during the winter months. So now I'm going to switch to do some galaxy and globular cluster photography. So first thing I need to do is actually go to the home position, and then I'm going to switch my camera actually to the 678 MC planetary camera to get a little extra boost in magnification and utilize some of those smaller pixels. And I'm going to switch the filter now from my Optolong L Extreme to Zvibony UV IR cut filter, and we'll start with M101 galaxy, which is up there in the northern skies right now. That's the Pinwheel galaxy. New target, galaxy. 4 bells for galaxy. New target, galaxy. Here's my imaging rig with the new camera installed. Of course, I needed to refocus my rig, which I did on a star in the constellation of Ursa Major. Because my next target was M101, the Pinwheel galaxy. This target was in the northeast and on the rise, where I imaged it from about 1 o'clock until nearly 2:30 in the morning. The Pinwheel galaxy is 21 million light-years distant and appears at magnitude 7.9 when observed from our Milky Way location. It has a beautiful spiral structure and is a popular target. This one, I simply wanted to try from a darker sky to see what kind of details I could pull out from the Bortle Class 4 environment with my small pixel, small sensor planetary camera. I used a UV IR cut filter to keep the star sizes as pinpoint as possible. If you saw my Astrophotography Japan video episode number 12, you would understand that a single frame exposure in this camera always looks rather noisy with much less definition than I see with the 533 MC Pro camera. So the screenshot image I captured here looked rather typical to me. Certainly the guiding was doing very well at 0.64 arcseconds RMS error. Unfortunately, it was not until much later, after moving to my next target, that I realized my very disappointing mistake. Can you find it among the data displayed on this screen? Let me give you a hint. Look at the bottom left corner. Apparently, when I set up this new camera earlier, there was one parameter that I neglected to check, the gain setting. For this camera, the ideal gain setting is about 185. For some reason, it was set to just 7 when I installed this camera, and I did not notice it. Therefore, the sensor read noise was near to its highest possible values. I hoped there was still a chance that I could develop the image, but on the left here is the image from 90 minutes of data out of Deep Sky Stacker. It was a wasted effort. Processing did not help. About 4 days later, frustration drove me to image this target again from my home backyard in Yokohama. Shown on the right is the processed image from 90 minutes of stacked data, but this time at a more proper gain setting of 195. I matched the orientation of these images and the integration times so they were aligned. And here is the full and final image from my backyard imaging site. It contains exactly 4 hours of integrated data. Oh well, next time I will be more careful on checking all of my settings. Zannen deshita ga kondo ganbarimasu. Translated, that means, it was regrettable, but next time I will do my best. That night, my location on that elevated oceanside bluff was remote and exhilarating. Despite the issues, I was still having a great time enjoying the night sky and natural surroundings. I took this 30-second image of the nearby cliffs below and sky over the ocean with my iPhone 11 camera. After a little enhancement, it looks like an impressionist painting, don't you think? Also, here is another view of the sky over the ocean around this time. The light trails at the bottom are ships on the water making streaks during the 30-second exposure. It was a beautiful sight. In this photo, you can start to see a hint of reddish character low to the horizon. At about 2 a.m., this color was from the rise of the Milky Way, as you can see it simulated in this Sky Safari application. And then, the next 3 photos following this simulation are some images I took trying to capture the Milky Way with my iPhone camera. Interestingly, from around 2 a.m. until sunrise, no less than 5 people visited this location with their cameras to image the Milky Way on this night. I think they were surprised to see me there, but very respectful with regard to using red lights and minimizing disruption to my equipment. I did have to warn them a few times, however, to be mindful of the telescope since my next target was extremely low to the horizon, and of course I did not want them to set up equipment or walk in front of the telescope. New target! Star cluster! 5 bells for star cluster! New target! My next target was the Omega Centauri star cluster. This is a fun target, not only because it is the biggest and brightest globular cluster visible in our galaxy, but it is also mostly a southern hemisphere target. At 35 degrees latitude here in Japan, it crosses the meridian with a maximum altitude of only 7 degrees above the horizon. I did my imaging from around 3 o'clock to 4 o'clock a.m., during which time it only changed about 1 degree in altitude. When I started imaging, I was still using the wrong gain setting on my 678 MC camera, but it was during the meridian flip that I noticed the erroneous setting. This target is so bright that only 30-second exposures was enough, and short exposures would be ideal to keep the star sizes minimized and sharp. Here are a few screenshots of a single frame capture with the image on the left at a gain setting of 7 and the image on the right at a gain setting of 195. Notice guiding was a bit worse on this target, but that is expected at this low altitude where we are imaging through an enormous amount of atmosphere that will inevitably disturb the photographic images. I love these green laser pictures. This one shows you how very low we are imaging in the sky to capture this cluster. This is only possible over the ocean here in Japan. And I really did not properly align this laser. It is just rubber banded into the Vixen clamp to give me a general sense of direction of the declination axis. I believe it is actually misaligned a few degrees too high in this photo. I decided to only capture a few minutes of data on this cluster because the dawn was approaching and I was more interested in another target. Unlike Nebula images, this one was super easy to process. The field of view of this 678 MC camera image is quite small, but perfect for this deep sky object. As you can see here, the image is quite magnificent for just 10 minutes of integration time. Interestingly, this was not the first time I imaged Omega Centauri. In the spring prior, I also imaged it, but with my tiny little Ascar FMA 135 lens. Shown here are the 2 images side by side. These were taken with different scopes and different cameras, showing a radically different image size of the cluster. But both are of remarkable quality considering their location so close to the horizon. Oh no! At this point, I noticed another potential problem. My battery was on the last bar and I wanted to capture one more target. So I turned down the power on my dew heaters a bit to conserve energy and moved to the next target quickly. New target, galaxy. 4 bells for galaxy. New target, galaxy. This target is a rather unique galaxy found in the Centaurus constellation. It actually happens to be the 5th brightest galaxy in the sky, but also is very low on the southern horizon when viewed from here in Chiba, Japan. It transits the meridian at about 12 degrees. The Centaurus A galaxy is about 13 million light-years distant and shines at a magnitude of 6.8. It has a very unique appearance due to a dark nebula or dust band that extends across the center of the galaxy from end to end. Centaurus A is located just above the Omega Centauri globular cluster, which is the circle with the X mark seen below in this Sky Safari simulation. And here is a single exposure of the galaxy at 180 seconds. It was only a few degrees above Omega Centauri, but the guiding here was surprisingly better at sub-arc-second accuracy. During this imaging at around 4:45 a.m., I noticed the battery was now near to being fully drained. It was flashing at me to get my attention. At first I thought, so what? I will just let it run out and capture as many images as I can. No big deal. But then it dawned on me. If this battery dies, my AM5 mount will be stuck in that position and I would not be able to put it back into the home position because the mount does not have any clutch mechanisms for each of the axes. That means I could not put the mount back into the case since the case only accepts the mount in the EQ mode home position. Yikes, that would really be a significant transport problem for me. How would I bring it back to the hotel and back home? I purposely did not bring along the charger on this trip because I did not think I needed it. So I made the decision to terminate my imaging at about 5 a.m. after 1 hour of tracking the Centaurus A galaxy. That would have to be enough. The inconvenient risk of battery failure was too great. I sent the rig to the home position and shut down the mount in ASI air for the night. Luckily, I had enough power to do that. That 109,000 milliamp-hour battery supported my imaging with 2 dew heaters and ran for about 11 straight hours during a winter night near to freezing temperatures. I'd say it was a good investment, and I'm very satisfied with its performance. Of the 20 images I captured of Centaurus A, I used 16 of them for stacking. Here I used StarNet++ to help in the image processing, and the results looked quite fine for only 48 minutes of data. I am pleased with the performance of the 678 MC planetary camera in imaging of this galaxy. There are some pretty good details evident when you zoom into this image. Here is a close-up of the 3 successful images that I captured during this night. I made a few mistakes, I learned a few lessons, but most importantly, I had a great time appreciating the vast and surprising universe above and the beautiful natural surroundings down here below on Mother Earth. This trip to Chiba was again another worthwhile adventure, adding to my experience, image portfolio, and skills development in astrophotography. Thank you for joining me for another episode of Astrophotography Japan. Here is wishing you clear skies for your own astrophotography imaging adventures. By all means, strive for the best images, but don't forget to enjoy the pursuit. I hope you join me again as I visit more of the sights, skies, and locations for exploring astrophotography in Japan. My name is Paul Cheesegel, and I am an astrophotographer.